So it's coming up towards the end of the first 9 weeks, and we're going to now start to enter Unit 4, which is going to be titled Proportionality. Now, in this unit, we're going to rely heavily on your knowledge of division, of equivalent fractions, of how to solve simple equations, and of how to simplify. Okay, so there's going to be a wide range of topics that we study in this unit, but it's all going to come down to one thing, and that's using proportions in order to basically solve all of them. Okay, and there are four basic methods that you use in order to solve proportion problems, which I'm going to go through this video. Okay, so first though, let's start with some definitions. We have ratios and rates. So if you look over here, these two drawings represents ratios. So what a ratio is, it's a comparison of two or more quantities with the same unit. So in this case, our unit is gender. We have girls versus boys, or males versus females, and then over here we have shapes. Okay, so we're comparing red versus blue, but it's the same unit. We're still talking about shapes here. Okay, so let's take a look at this. So I could say that there are 4 boys for every 6 girls here, right? I could also simplify this. I could say that the ratio of boys to girls is 2 to 3, or I could flip it around and say the ratio of girls to boys is 6 to 4. The simplified ratio of girls to boys is 3 to 2. So it matters what order you say it. Okay? So we could write our ratios like this. We could even write them as fractions as long as we label them. So this is going to be boys, and then we have girls. And then we could also just write it out in words. We could write 4 to 6. Okay? Now, of course, there's this ratio, but we also could see that there's a total ratio. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in total. So I could say the ratio of boys to the amount of students in the class is going to be 4 to 10. Or I could simplify that to say 2 to 5. I could also simplify that. Well, no, that's it. So I could say there's a 2 to 5 ratio of boys to total people in the classroom. I could also say that there's a 6 to 10 ratio of girls to total people in the class, or I could say 3 to 5 ratio of girls to total people in the class. Okay, so I hope you're understanding that we could compare both girls and boys, but we could also compare boys to the total and girls to the total. Like over here, our ratio from red to blue is going to be 3 to 1, 2, 3, 4, 5, 6, 7. 3 to 7. So I could clearly see that there's a total of 10. Okay? So I could say the ratio of blue to the total is going to be equal to 7 to 10. Okay? Now, when we're talking about a rate is a comparison of 2 or more quantities, but this time with different units. So you think about science, you think about rate of change, but what I really think about when I think about this is cars. So miles per hour. Okay, so in Texas, well, in Houston in particular, on a highway, cars are allotted a speed limit of 60 miles per hour. Okay, this is actually a unit rate, but we'll discuss that later. Okay, so let's talk about an example. So let's say a car burns 20 liters of gas every 200 kilometers. As you can see, I'm comparing liters of gas to kilometers. So I'm dealing with different units here. I'm dealing with distance down here, and then I'm dealing with capacity here. Okay, so this will be called a rate as opposed to a ratio because I'm dealing with different units. And of course, I could simplify this to 1 liter for every 10 kilometers. All right, and this will also be my unit rate. So this is just the rate, but these two are unit rates. The reason why, because of this 1 unit here. Okay? All right, so let's talk about the different ways that we could solve these ratios and rate problems while using proportions. So the first thing to do is to set up an equivalent ratio. 4 times what number is going to be equal to 36? Now, this one is simple. Times 9 times 9. So in this case, we got 25 times 9 is going to be equal to x. So x, our missing number of miles, is going to be equal to 225 miles. Okay, so I just could see that I could easily multiply 4 times 9 in order to get 36, so I went with equivalent ratios here. Now this is called a cross product. The reason why it's called a cross product is you're multiplying the numbers diagonal and then you're setting them equal to each other in order to create a simple equation, and then you'll solve for x. So this is 4 times x. I'm going to multiply the diagonals. 4 times x is going to be equal to 36 times 25. So 4 times x, 36 times 25 is 900. Divided by 4, divided by 4. We get x is going to be equal to the same thing, of course, 225 miles. Okay, so this one, if you could see it easily, then go ahead and use an equivalent ratio. But you wouldn't want to do that for, if you're comparing like 4 hours to, let's say, like 17 hours over here. You would want to use something else such as the cross product. Okay, so there are actually 2 more. We have equivalent ratios and then we have cross product. Now we have what's called a unit rate. So this might be the most important one that'll carry you through this entire unit. Okay, so basically what a unit rate is it takes a rate and puts it in terms of one quantity. Okay, so let's take a look here and I'll explain. We have 25 miles for 4 hours. Okay, we want to figure out how much is in 36 hours. Well, we could just find our unit rate and figure out how much is per 1 hour. And then from there, we could basically figure out for how many hours we want, because this wouldn't be very specific. It'll be a general statement for the unit rate. So in order to find the unit rate, all you really have to do is create a proportion, and then you're going to divide by the denominator. Okay, so 25 divided by 4 is going to leave me with 6.25 miles. So what I could say is that for every 1 hour, I'll travel 6.25 miles. This is my unit rate. And then from here, I could figure out how many ever miles I want. 36, 74, 83, 83 and a half. So it just makes this a lot easier. So 36 hours, so multiply by 36. It's my scale factor, multiply by 36. So x is going to be equal to 225 miles. Okay? Now, this last one, we probably won't use it as much as very lengthy, but at the same time, it gives you a very good understanding and a very good concept of what's going on. So, in order to set this up, make sure you have both of your units here. So, I start with 4 hours, and then I'm going to add 4, 8, add 4, 12, 16, 20, 24, 28, 32, and 36, which is my target. Okay, so I'm just increasing the hours at a rate of 4 hours. Here, of course, I'm going to increase the miles at a rate of 25 miles. So I start off with 25, 50, 75, 100, 125, 150, 175, 200, and then finally 225. So I could figure it out this way. Now, there's one more thing I want you to notice. So you see how we have 25 miles, and then 4 hours, and then X miles, and then 36 hours. I've been trying to multiply this way or divide that way, but notice that you could go up and down as well. You don't always have to go horizontal. You could actually go vertical as well. Now, in order to do that, all you have to do is figure out over here 25 divided by what equals 4. And as you can see, we've already figured that out. It's divide by 6.25. Alright? So, I went from the numerator down to the denominator. If I go from the denominator up to the numerator, instead of dividing by 6.25, I can multiply by 6.25. So essentially, I'm just doing the same thing over here. And then, of course, I'll get X is once again equal to 225 miles. Okay, so let's just practice a couple of word problems, and that'll be it for this video. A Ferris wheel can accommodate 36 people in 20 minutes. So I'm going to go ahead and write that. 36 people in 20 minutes. How many people can it accommodate in 50 minutes? Well, I want to go ahead first and match the minutes and the minutes. So this is going to be 50 minutes. So 20 times what is going to be equal to 50? If you can't figure that out, just go ahead and divide. Okay? So it's going to be multiplied by 2.5 and then multiplied by 2.5. So X people, 36 times 2.5 is going to be equal to 90 people. Okay? So as you can see, in this one, I just used the equivalent ratio. Notice that you could have done cross product. You could have also done a unit rate first, and then from that unit rate just multiplied by 50, or you could have created a table. Okay, so for this one, I'm going to try a different method. Anna needed chocolate, so she went to H-E-B. She could buy 12 chocolate bars for $24. So I'm going to put the $24 at the top, and I'm going to put the 12 chocolate bars down here. What would the cost of 96 chocolate bars be? So 96 bars, and then we have X dollars. Okay, so for this one, I'm going to go ahead and try to use cross product. So to do cross product, we have 12 times X, which is equal to 12X, and then we have 96 multiplied by 24. Now, all I have to do at this point is multiply 96 by 24. I get 2,304, and then we have 12x. So I'm going to divide by 12 and divide by 12. So x, in this case, is going to be equal to $192. Now, when it comes to all four methods, you have to try to figure out which one makes sense. In this case, I probably should not have used cross product because of how big these numbers are. If I would have just done something like unit rate or equivalent fractions, it would have been a lot easier, because I could see that 12 goes into 96. It goes into 96 8 times. So I could have just multiplied 12 times 8 to get 96 and done 24 times 8 to get 192. So you really have to try to understand what's going on in order to do these problems, and just pick the right method that'll save you the most time. Okay?